When the term hybrid vehicle is used, it most often refers to a hybrid electric vehicle. These encompass such vehicles as the Saturn V, Toyota Prius, Toyota Yaris, Toyota Camry Hybrid, Ford Escape Hybrid, Ford Fusion Hybrid, Toyota Highlander Hybrid, Honda Insight, Honda Civic Hybrid, Lexus RX 400h and 450h, Hyundai Ioniq, and others. A petroleum-electric hybrid most commonly uses internal combustion engines, using a variety of fuels, generally gasoline or diesel engines, and electric motors to power the vehicle. The energy is stored in the fuel of the internal combustion engine and an electric battery set. There are many types of petroleum-electric hybrid drivetrains, from full hybrid to mild hybrid, which offer varying advantages and disadvantages. William H. Patton filed a patent application for a gasoline-electric hybrid railcar propulsion system in early 1889, and for a similar hybrid boat propulsion system in mid-1889. There is no evidence that his hybrid boat met with any success, but he built a prototype hybrid tram and sold a small hybrid locomotive. In 1899, Henry Piper developed the world's first petro-electric hybrid automobile. In 1900, Ferdinand Porsche developed a series hybrid using two motor in-wheel hub arrangements with an internal combustion generator set providing the electric power. Porsche's hybrid set 2-speed records. While liquid fuel/electric hybrids date back to the late 19th century, the braking regenerative hybrid was invented by David Arthurs, an electrical engineer from Springdale, Arkansas, in 1978-79. His home-converted Opel GT was reported to return as much as 75 mpg with plans still sold to this original design, and the Mother Earth News modified version on their website. The plug-in electric vehicle, PEV, is becoming more and more common. It has the range needed in locations where there are wide gaps with no services. The batteries can be plugged into house, mains, electricity for charging, as well being charged while the engine is running. Some battery electric vehicles can be recharged while the user drives. Such a vehicle establishes contact with an electrified rail, plate, or overhead wires on the highway via an attached conducting wheel or other similar mechanisms. See conduit current collection. The vehicle's batteries are recharged by this process on the highway and can then be used normally on other roads until the battery is discharged. For example, some of the battery electric locomotives used for maintenance trains on the London Underground are capable of this mode of operation. Developing an infrastructure for battery electric vehicles would provide the advantage of virtually unrestricted highway range. Since many destinations are within 100 kilometers of a major highway, this technology could reduce the need for expensive battery systems. However, private use of the existing electrical system is almost universally prohibited. Besides, the technology for such electrical infrastructure is largely outdated and, outside some cities, not widely distributed. See conduit current collection, trams, electric rail, trolleys, third rail. Updating the required electrical and infrastructure costs could perhaps be funded by toll revenue or by dedicated transportation taxes. In addition to vehicles that use two or more different devices for propulsion, some also consider vehicles that use distinct energy sources or input types, fuels, using the same engine to be hybrids, although to avoid confusion with hybrids as described above and to use correctly the terms, these are perhaps more correctly described as dual-mode vehicles. Some trolley buses can switch between an onboard diesel engine and overhead electrical power depending on conditions. See dual-mode bus. In principle, this could be combined with a battery subsystem to create a true plug-in hybrid trolley bus, although as of 2006, no such design seems to have been announced. Flexible fuel vehicles can use a mixture of input fuels mixed in one tank, typically gasoline and ethanol, methanol, or biobutanol. Bi-fuel vehicle, liquefied petroleum gas and natural gas are very different from petroleum or diesel and cannot be used in the same tanks, so it would be challenging to build an LPG or NG flexible fuel system. Instead, vehicles are built with two parallel fuel systems feeding one engine. For example, Some Chevrolet Silverado 2500 HDS can effortlessly switch between petroleum and natural gas, offering a range of over 1,000 kilometers, 650 miles. While the duplicated tanks cost space in some applications, the increased range, decreased cost of fuel, and flexibility where LPG or CNG infrastructure is incomplete may be a significant incentive to purchase. While the U.S. natural gas infrastructure is partially incomplete, it is increasing and in 2013 had 2,600 CNG stations in place. Rising gas prices may push consumers to purchase these vehicles. In 2013, when gas prices traded around $1.10 per liter, $4.0 gal, the price of gasoline was $95.50 per megawatt hour, $28 per million British thermal units, compared to natural gas's $13.6/MWh, $4 per million British thermal units. On a per unit of energy comparative basis, this makes natural gas much cheaper than gasoline. Some vehicles have been modified to use another fuel source if it is available, such as cars modified to run on autogas, LPG, and diesels modified to run on waste vegetable oil that has not been processed into biodiesel. Power assist mechanisms for bicycles and other human-powered vehicles are also included. Hydraulic hybrid and pneumatic hybrid vehicles use an engine or regenerative braking, or both, to charge a pressure accumulator to drive the wheels via hydraulic, liquid, or pneumatic, compressed gas, drive units. In most cases the engine is detached from the drivetrain, serving solely to charge the energy accumulator. The transmission is seamless. Regenerative braking can be used to recover some of the supplied drive energy back into the accumulator. Another form of a hybrid vehicle are the human-powered electric vehicles. These include such vehicles as the Sinclair C5, Twike, electric bicycles, electric skateboards, and electric motorcycles and scooters. A series or serial hybrid vehicle is driven by an electric motor, functioning as an electric vehicle while the battery pack energy supply is sufficient, with an engine tuned for running as a generator when the battery pack is insufficient. There is typically no mechanical connection between the engine and the wheels, and the primary purpose of the range extender is to charge the battery. Series hybrids have also been referred to as extended range electric vehicle, range extended electric vehicle, or electric vehicle extended range, EREV/REEV/EVER. The BMW i3 with range extender is a production series hybrid. It operates as an electric vehicle until the battery charge is low, and then activates an engine-powered generator to maintain power, and is also available without the range extender. The Fisker Karma was the first series hybrid production vehicle. When describing cars, the battery of a series hybrid is usually charged by being plugged in, but a series hybrid may also allow for a battery to only act as a buffer, and for regeneration purposes, and for the electric motor's power to be supplied constantly by a supporting engine. Series arrangements have been common in diesel-electric locomotives and ships. Ferdinand Porsche effectively invented this arrangement in speed record-setting racing cars in the early 20th century, such as the Lohner, Porsche Mixed Hybrid. Porsche named his arrangement system Mixed, and it was a wheel hub motor design, where each of the two front wheels was powered by a separate motor. This arrangement was sometimes referred to as an electric transmission, as the electric generator and driving motor replaced a mechanical transmission. The vehicle could not move unless the internal combustion engine was running. In 1997, Toyota released the first series hybrid bus sold in Japan. GM introduced the Chevy Volt series plug-in hybrid in 2010, aiming for an all-electric range of 40 miles 64 kilometers, though this car also has a mechanical connection between the engine and drivetrain. Supercapacitors combined with a lithium-ion battery bank have been used by AFS Trinity in a converted Saturn VW SUV vehicle. Using supercapacitors, they claim up to 150 mpg in a series hybrid arrangement. Nissan Note e-Power is an example of a series hybrid technology since 2016 in Japan. Another subtype of hybrid vehicles is the plug-in hybrid electric vehicle. The plug-in hybrid is usually a general fuel electric, parallel or serial, hybrid with increased energy storage capacity, usually through a lithium-ion battery, which allows the vehicle to drive on all-electric mode a distance that depends on the battery size and its mechanical layout, series or parallel. It may be connected to mains electricity supply at the end of the journey to avoid charging using the onboard internal combustion engine. This concept is attractive to those seeking to minimize on-road emissions by avoiding or at least minimizing the use of ICE during daily driving. As with pure electric vehicles, the total emissions saving, for example in CO2 terms, is dependent upon the energy source of the electricity generating company. For some users, this type of vehicle may also be financially attractive so long as the electrical energy being used is cheaper than the petrol/diesel that they would have otherwise used. Current tax systems in many European countries use mineral oil taxation as a major income source. This is generally not the case for electricity, which is taxed uniformly for the domestic customer, however that person uses it. Some electricity suppliers also offer price benefits for off-peak night users, which may further increase the attractiveness of the plug-in option for commuters and urban motorists. A 2009 National Highway Traffic Safety Administration report examined hybrid electric vehicle accidents that involved pedestrians and cyclists and compared them to accidents involving internal combustion engine vehicles, ICEV. The findings showed that, in certain road situations, HEVs are more dangerous for those on foot or bicycle. For accidents where a vehicle was slowing or stopping, backing up, entering, or leaving a parking space, when the sound difference between HEVs and ICEVs is most pronounced, HEVs were twice as likely to be involved in a pedestrian crash than ICEVs. For crashes involving cyclists or pedestrians, there was a higher incident rate for HEVs than ICEVs when a vehicle was turning a corner. However, there was no statistically significant difference between the types of vehicles when they were driving straight. Several automakers developed electric vehicle warning sounds designed to alert pedestrians to the presence of electric drive vehicles such as hybrid electric vehicle, plug-in hybrid electric vehicles and all-electric vehicles, EVs, traveling at low speeds. Their purpose is to make pedestrians, cyclists, the blind, and others aware of the vehicle's presence while operating in all-electric mode. Vehicles in the market with such safety devices include the Nissan Leaf, Chevrolet Volt, Fisker Karma, Honda FCX Clarity, Nissan Fuga Hybrid/Infiniti M35, Hyundai 935 FCEV, Hyundai Sonata Hybrid, 2012 Honda Fit EV, the 2012 Toyota Camry Hybrid, 2012 Lexus CT200H, and all the Prius family of cars. The hybrid vehicle typically achieves greater fuel economy and lower emissions than conventional internal combustion engine vehicles, ICEVs, resulting in fewer emissions being generated. These savings are primarily achieved by three elements of a typical hybrid design. Relying on both the engine and the electric motors for peak power needs, resulting in a smaller engine size more for average usage rather than peak power usage. A smaller engine can have fewer internal losses and lower weight. Having significant battery storage capacity to store and reuse recaptured energy, especially in stop-and-go traffic typical of the city driving cycle. Recapturing significant amounts of energy during braking that are normally wasted as heat. This regenerative braking reduces vehicle speed by converting some of its kinetic energy into electricity, depending upon the power rating of the motor/generator. Other techniques that are not necessarily hybrid features, but that are frequently found on hybrid vehicles include using Atkinson cycle engines instead of Otto cycle engines for improved fuel economy, shutting down the engine during traffic stops or while coasting or during other idle periods, improving aerodynamics. Part of the reason that SUVs get such bad fuel economy is the drag on the car. A box-shaped car or truck has to exert more force to move through the air, causing more stress on the engine, making it work harder. Improving the shape and aerodynamics of a car is a good way to help better the fuel economy and also improve vehicle handling at the same time. Using low rolling resistance tires, tires were often made to give a quiet, smooth ride, high grip, etc., but efficiency was a lower priority. Tires cause mechanical drag, once again making the engine work harder, consuming more fuel. Hybrid cars may use special tires that are more inflated than regular tires and stiffer, or by choice of carcass structure and rubber compound have lower rolling resistance while retaining acceptable grip, and so improving fuel economy whatever the power source. Powering the AC, power steering, and other auxiliary pumps electrically as and when needed, this reduces mechanical losses when compared with driving them continuously with traditional engine belts. These features make a hybrid vehicle particularly efficient for city traffic where there are frequent stops, coasting, and idling periods. In addition, noise emissions are reduced, particularly at idling and low operating speeds, in comparison to conventional engine vehicles. For continuous high-speed highway use, these features are much less useful in reducing emissions. Hybrid vehicle emissions today are getting close to or even lower than the recommended level set by the EPA, Environmental Protection Agency. The recommended levels they suggest for a typical passenger vehicle should be equated to 5.5 metric tons of CO2. The three most popular hybrid vehicles, Honda Civic, Honda Insight and Toyota Prius, set the standards even higher by producing 4.1, 3.5 and 3.5 tons, showing a major improvement in carbon dioxide emissions. Hybrid vehicles can reduce air emissions of smog-forming pollutants by up to 90% and cut carbon dioxide emissions in half. An increase in fossil fuels is needed to build hybrid vehicles versus conventional cars. This increase is more than offset by reduced emissions when running the vehicle. Hybrids, electric vehicles, HEVs, combine the advantage of gasoline engines and electric motors. The key areas for efficiency or performance gains are regenerative braking, dual power sources, and less idling. Regenerative braking. The electric motor normally converts electricity into physical motion. Used in reverse as a generator, it can also convert physical motion into electricity. This both slows the car, braking, and recharges, regenerates, the batteries. Dual power. Power can come from either the engine, motor, or both depending on driving circumstances. Additional power to assist the engine in accelerating or climbing might be provided by the electric motor. Or more commonly, a smaller electric motor provides all of the power for low-speed driving conditions and is augmented by the engine at higher speeds. Automatic start/shut-off. It automatically shuts off the engine when the vehicle comes to a stop and restarts it when the accelerator is pressed down. This automation is much simpler with an electric motor. Also, see dual power above. Keep driving. Thank you for watching this video.